Hi, this is Hong from Team TayGood. For VHack, we choose case study 1. So we build out AI guided predictive maintenance, where one platform we can share it to 3 audience in 500%. So the problem we see from the problem statements, uh, we added a few as well, other than not only factory owners. So for factory owners, material failure are unpredictable. A single unplanned shutdown costs like 100,000 in loss in production. Current solutions are either too expensive or too simple mistake. For engineers, right, diagnosing spillers requires 2+ hours of manual analysis. Engineers rely on institution, not data when they are wrong. It costs millions. For students and innovators, predictive maintenance is a 50 billion market, but tools are locked behind expensive enterprise software. The barrier to entry is too high. So for our solution, right, we build out a guided wizard, which is for beginner and demos. So 6-step conversational flow, no domain knowledge required, 10 minutes diagnosis. And then for the expert dashboard where engineer uses it, there's a real-time S to N curve, what if calculator, historical comparison. And ML pipeline is for the researcher, data set upload and training, model evaluation, and extensible framework. If the engineer is expert enough, he can use expert dashboard and ML pipeline combined to create out a very accurate result. So for market opportunity, right, we see that the predictive maintenance market is projected to reach 50 billion by 2030. Industrial facilities worldwide are desperate for affordable, easy to deploy solutions. So enterprise will have a 30 billion market, education 5 billion market, and startup ecosystem is emerging like IoT companies, AI researchers, and startups. Okay, so why VHack win? Why our project? Why choose us? Because we do physics first instead of ML. And honest uncertainty, 95% CI transparency, not false certainty. Accessible rigor. We got guided wizard for the beginner, expert dashboard and ML pipelines, and 100 times cheaper and 100 times cheaper freemium versus. That's all. Thank you. So hi, this is Hong San again from TayGood. So now I'm gonna walk you guys through the demo. So imagine this scenario. So a real maintenance scenario. Imagine you are a plant manager at CNC manufacturing facility. One of your spindle bearing is showing signs of wear. You need to decide replace it now or wait. So with this application, we have our AI guided maintenance assessment and pronote. This can answer this question in 6 steps. So this is a spindle bearing for the people who don't know. So first we click CNC machine. We click bearing. Okay. Then we scroll down. Then we select depend what material you're bearing using, maybe a steel. I see. Okay, then you click continue. Uh, then you can like upload a sample of your bearing if you have it. So what defect you observe, so you can like maybe you say there's like 2 defect, but the defect can be not more than 5 here because from what I research is if it's more than 5, I don't think the thing can be used. So for example, 2, there's like where moderate visible groove location, maybe lock nut. Okay, and then deformation again. Moderate. Okay, maybe at the lock nut as well. Okay, then the stress amplitude maybe 100. Cycle 1 million. Zero. Okay, then select bending, and then interest. It makes sense. Okay. Okay, then we'll diagnose it. So overall score is 0 out of 100. It's a very critical thing now, so must change really. So fatigue is 1000 cycle, demonstration 1000, safety factor 0.3. You can see all the details at the correction factor applied. Warning stress amplitude 500, acid seals. So plastic deformation expected. Vision expected. Expectation. Maintenance recommendation, immediate shutdown. Show S and curve as well. Then you can save the history. So it's like what if analysis in the future and new inspect. So hi, now I'm going to show expert dashboard where engineer uses it. For example, CNC machine again same thing, and then component which is back again. Material will go with the same thing as for steel, stainless steel. Mean stress I'll change it to stress amplitude I'll change it to 400, and then yeah, all these things. The same deformation, I guess. Moderate. And wife calculator. Steel also. I said 3, 4. So quick analysis. What if? So now I'm going to show what if calculator. So fatigue life versus stress amplitude. We show everything here. Safety factor versus stress amplitude. We show. So as this goes, actually this method is already below the safety factor, so I have to change it or monitor it. So analysis is also critical. So timeline is 0 day, meaning that you have to change it now, else you have to shut it down now because it's. Lastly, I'm going to show you guys my code where I inserted a physics formula into it. I researched using Mainers AI. And so we have Baskin's equation, real physics, Goodman correction, mean stress effects, and then marine factors, surface size, loading, temperature, 11 stress concentration, geometrics, 9 real engineers, alloys, 95% confidence intervals, and then minor rules for variable loading. That's all, thank you.